Well, thank you very much, Susie. That was a great introduction. It's not often you get an opportunity to start up a program from scratch. It's been a great year. It's been very exciting. Actually, you know, I'm a mathematician, so earlier this morning we heard that this the next decade is all for me, right? Mathematicians. It's going to be a great year. But what I should let you know is that I am not an expert in high-performance computing, and I'm not an expert in manufacturing. So it was the obvious choice to be the director for HPC4MFG. But what has made the program successful is the collaborations of those experts that I'm working with, those at Lawrence Livermore National Laboratories, as well as Berkeley and Oak Ridge. And we have really formed a trusted partnership that's doing the right thing for the right reasons, which is a nice thing to see amongst the national. Okay. Susie did a great job of kind of giving an overview of the program. So I'm going to start by talking a little bit about why we're doing the program, kind of its humble beginnings. I'll explain the program a little more, talk about some of the projects and some of our challenges. So I'd like to start out by asking raise your hand. When you were going to college, or when you're going to school and you're dreaming about what you wanted to be when you grew up, or even a mid-career, how many of you thought, I want to work in manufacturing? Okay, so we have a couple people. That's not often the case. Manufacturing has kind of a poor image. I learned they call it the 4 Ds. It's considered dirty, dark, dangerous, and declining. And it has been declining. The U.S. manufacturing has been declining over the last several decades. A lot of manufacturing is done the way it was done 50 years ago. A lot of manufacturing is very, very energy intensive. But some of the manufacturers have adopted higher technologies, in particularly high performance computing, and they've really shown the benefit of it. So the program is all about how can we leverage that and move all of the industries forward out of manufacturing and really help them be more economically competitive. Okay, so if the U.S. wants to help improve the U.S. manufacturing, what can they do? They've got an ace in their pocket because the national labs excel in high-performance computing. They're amongst the leaders of the world in that industry. So, we've got great high-performance computing. High-performance computing has been shown by multiple different pilots and by some of the manufacturing companies to have a big impact on energy innovation, or just innovation in manufacturing. We got a number of manufacturing companies that need to adopt it, right, whether they know it or not. And some do, some don't. And the ones I list here are the most energy-intensive manufacturing. So this seems to be a great partnership. Let's just partner these guys together and it will work. However, there's a big divide between the national labs and industry. Some of the industry, they don't know how to use high-performance computing. They don't know how to engage with the national lab. If you don't know what you don't know, it's a hard divide to cross. So, how do we cross that? The Advanced Manufacturing Office at DERE, led by Mark Johnson, decided that he became aware of several different pilot projects. Endemic, I think many of you might know, was led by Council on Competitiveness several years ago. HPC4MFG was led by Livermore, both pilot projects that partnered the labs with industry as a proof of concept to adoption of high-performance computing. He thought this was great, and he was ready. He feels he owns the responsibility of moving U.S. manufacturing forward. So he's the one that started up the program. The main tenets of the program are shown here. So first, you have to have projects, executing projects between the national labs and industry. You've got to do it in a very streamlined fashion because you have to work at industry pace. You need to share what's learned from those experiences, so not just company A gets improvement, but the industry, when you float the boat, all of industry knows about it and can leverage that. And you need to build the HPC manufacturing community. As I said before, not a lot of people have been drawn into manufacturing, so their workforce is aging and they're having a very difficult time attracting high tech. So the projects, I'll go back to those. The projects come in two flavors. The phase 1 projects are intended to demonstrate to that industry that HPC can make a difference in their company. It can have an impact, has a good return on investment. The projects are year-long projects. They're capped at $300,000. That money funds the national lab scientist and the cycles, pays for the cycles on the computers, to partner with the company. The company puts up 20% cost share. They really need skin in the game to help define what that problem is, providing enough data and information for the modeling and simulation or advanced analytic needs, and then of course to help validate results. Phase 2 projects are kind of lessons learned from some of those other pilots. The phase 2 project is, now that you've demonstrated high performance computing can have an impact, how do you incorporate that and implement that into that industry, into that company? The thought before was that if you just need to demonstrate it, but it is quite a gap if you've not done or not knowledgeable with high performance computing, if you don't have the systems, if you don't have the expertise in-house, it's hard to make that implementation. So the thought of this program is we want to lower the barrier of entry. We want to make it easier for industry to try out high performance computing, and that's what this is all about. So I'm going to go into a couple examples of projects to give you a flavor of what the program funds. The first is we're partnering with Agenda 2020. Agenda 2020 is a consortium of paper-making companies. And the biggest challenge of paper-making companies, the biggest cost, the biggest energy-intensive area is in drying paper. Right? It starts as a mush, and it's in drying paper. So this is a project that we have both Livermore and Berkeley partnering on it to develop a model, both a continuum and a core-based model that models how the press works. So when you press the paper, all the water out of the paper, what they found was when you release the press, water soaked back into the paper and caused additional drying needs. So if they could solve this problem, or even have an impact on this problem, they think they can get a 20% return of hundreds of millions of dollars a year. So what we've done so far, we're not through with the project, we're kind of in the middle, but if you look here at here's the paper and here's the felt, you can see how it starts wet, you press down, and it gets really dry here, but when you release, water's seeping back in. So they've been able to model that so far. This is only the continuum, they're adding the pore space capability. Steel manufacturing, and we heard about steel manufacturing earlier today. So the steel manufacturing, we partnered with Purdue Calamute's consortium. They have a consortium of steel manufacturers. And the issue with steel manufacturing is the blast furnace itself. A lot of steel manufacturing is done like it was done 50 years ago. They don't have a lot of knowledge of exactly what goes on inside a blast furnace. The mixing, they just are operating blast furnace by their gut, right? So the people that have done it for a long time, they got a feel of it. But they don't know what's happening. So Purdue Calamute has actually developed a code, actually several different codes, that model different parts of the blast furnace. But the codes aren't efficient. They're not high performance, they're not parallel, they're not high performance. And they only do part of the problem. So they've actually been successful at helping, but they can't go any further than they are right now because they need to model larger problems. So, I should say in the past example, the two codes that were in use were laboratory codes. This one, of course, is an academic code. And so Livermore is actually working with them to speed up their code and improve their code. So the phase 1 was just an improvement on the code, and we got significant improvement on the code. The phase 1 was actually short, it was only a half year. It was understanding the code, providing the optimization and improvements to get this kind of a speed increase or performance performance increase and run a bunch of several paramedics studies for the steel companies. The phase 2 project this project is going to go into phase 2. The phase 2 project here will be actually taking the 3 different individual codes, integrating them together, rewriting it, and running on a high-performance system. So the last one is energy-efficient lighting. Here we're partnering with Sora, who's a lighting company. And Sora is developing wide bandgap gallium nitride. But they've done it on a small scale. They need to really understand how to model the growth, the gallium nitride crystal growth, to get to the wide bandgap. And so they're working with an expert in Livermore on modeling that capability. They predict that if they can get if they can be successful, they'll reduce their production cost by 20%. But more importantly, I think, it's enabling the development of the next generation power electronics. So far they've been able to model it. They've shown a lot more complex structure than they expected before. That's not unusual. And they can predict the flows successfully. So now they're working, the second part of the process is really how do you now optimize to make that. Okay, so that was just trying to give you a flavor. And again, some of these projects, some of them use lab codes, some of them use industry codes, and some of them use commercial codes. We've got a mix of all of them, almost in equal measures. Okay, so how does the program operate? So I'll first touch upon the solicitation process. It's a very similar commons two-phase solicitation process. First, we start by wide announcement using FedBizOps and many distribution mechanisms, announcing it to U.S. industry. So the eligibility are U.S. in manufacturers. We asked for a 2-page concept paper, and we formed I probably say we're actually in the process of the solicitation now. So our current solicitation is going to be open until April 21st. So spread the word. So we formed a technical merit review team that consists of members of the 3 national labs plus a member of the AMO, the technical program manager at AMO. They're the technical review committee, and they do the down select of the concept papers. But what I think is unique and special about the program is that at this point in time, once you down select the concept papers, we assign an expert, high performance computing expert, to that company to help to co-develop the proposal. And the reason this is needed is because if a company does not have high performance computing expertise, it's darn near impossible to actually develop a reasonable proposal. With this involved, you're already engaging the company, and the resulting proposal you're pretty sure it's going to be executable. So we move forward, the full proposals come in, committee meets again, we down select to a portfolio sized by the funding availability, and we try really hard to look at that portfolio having mostly impact, right? So you saw in the 3 proposals, or the 3 projects, there's significant impact, hundreds of millions of dollars kind of level impact. So that is one of the highest criteria, but also we try to look for a diversity in the portfolio. So we range from small companies to very large companies, people who are just adopting, people that are pushing the envelope. We want different manufacturing sectors. So we try hard to create a diverse portfolio. We provide that to AMO, and they do the approval. The other unique part of the program is that we provide significant feedback to all submitters. Not only the people that we're awarding, because we'll give them feedback to, yes, you're awarded, but here's things you might want to consider to make your project better, but also we give significant feedback to the people that we are not awarding. Because, again, this program is aimed at working with the manufacturing industry to help them adopt high-performance computing, because they just are unaware. So we need to work with these companies to let them know, how do you make the proposal better? Let's work on the statement of work. Let's work on the process. So we've worked, since our first solicitation, we've worked with a number of companies to help those proposals improve, and I expect we'll get more proposals from the same ones that are improved proposals in the next solicitation. So, whoops. The thing that came as a surprise to me, or surprise, but overwhelmingly, we heard repeatedly from the industry that the thing that they really loved about this project is that they did not have, it is the pairing of the PI to the industry. They did not have to know what was going on in all of the national labs. Who do I contact? How do I engage with the labs? They didn't have to know that. They just bring their problem to us. We pair them off. Here, sign here on the CRADA, and everything runs smoothly after. So that was great. So the program is kind of considered a one-stop shop for this kind of engagement. Okay, so the program stood up pretty quickly. It's been only a year, and since then, Livermore started up the program. We selected 5 seedlings. The 3 that I showed were 3 of those. 5 seedlings to start up and run through to kind of cut our teeth on the process to make sure that this is going to be efficient and effective. We conducted significant outreach. So I've been on the talking circuit for a year now, but not only in forums like this, but we would visit sites. We'd contact the companies themselves, or leaders in the companies themselves, people that we felt could utilize this, and we would actually go on site to the companies and talk to them. And this was probably one of the funnest parts of the program, because there are times where we would enter a room and all the team leads in the manufacturing would be around the table. You'd spend 10 minutes talking about the program, and then they would brainstorm kind of in front of us on, well, what could we do? What about this? What about this? And we'd be able to give them real-time feedback. So that was a lot of fun. So then by September, we had the other 2 labs on board, a consensus about how we were going to run the program, and we issued our first solicitation, which was last September. We awarded just last month $3 million, 10 projects to 8 companies. Now we're running in steady state. So it's been a year. So we've got the 5 seedlings. We've got 10 projects out of the first solicitation. We just announced the next solicitation. We established summer internships at each of the national labs this summer to bring summer students, to get students involved, to start growing that community. And we've identified our first phase 2 project, which is the steel mill project. So going forward, what are the challenges? Well, going forward, what are we going to do? We are now in a twice-a-year cycle. So we're going to be running solicitations every spring and fall. We're going to conduct something called an annual industry day. I'm actually hoping to get a better word for this. So if you think of something really clever, let me know. I think industry is boring. But what we're going to do is we're going to hold a day in which we invite industry to come hear about the program, hear about the successes and the projects, and get feedback from them. Both to inform them that this is happening and showcase some of the return on investments, but also get input on how can we make it even better. And then a lot of focus needs to be placed on building that community, building the HPC community within manufacturing. So we're talking about a lot of continued outreach, as I talked about before, but also building maybe internship programs. This year we've got summer students at each of the labs, but next summer, what if we had summer programs at the labs where professors are there and they're teaching things that are relevant to the cross-section between manufacturing and HPC. And industry interns. Let's get the companies to send an intern to the labs, or let's have people at the lab go out and stay at the something that will really help foster and raise the boat and foster a community. And I think it's very important that we include more labs, right? 3 labs are great, 4 would be better, more would be better. The more diversity, because every additional lab brings more diversity and more strength. So we're trying hard to grow the program so that we can enable ourselves to bring on more staff labs. I'm not going to talk to all of these lines, but these are the current projects, the 10 that came from the first solicitation and the 5 that came from the original seedlings, is what we call them. And they kind of fall into 3 buckets. They're either focused on optimizing their process to make it more energy efficient and more automated, or improving their design. Right? How can you do a better design before you build the part? And then, of course, the computational tools. Better tools really helps the entire community. And as you'll see, there are a number of different companies. Zoom Essence is a very small company. It has a process of drying spices, right? A new concept on how to dry spices. And you'll see large companies. You got GE and PPG and P&G. So there's quite a mix. You've got Lyft, which is a new institute that stood up, and several consortiums, universities. So it's a quite a diverse set of project types and people. The challenges remain, right? So this is what keeps me up at night. The things that I think about that keeps me up at night. And some of these, I think I grew hope from after sitting here for the last couple of days. The outreach to industry that doesn't know they need it yet. Right? Those companies that could utilize and would have a big impact for them and allow them to move forward and keep competitive in the market, yet they don't know that yet. They're just doing the same thing they've been doing, and their costs, their market shares continue to decrease. How do you get to those people? Right? We're trying really hard to do that through the methods that I've already talked about, but are there other methods? I think we need to be more inventive on how to touch these. Because you can give all the promotions you want, but if they don't think they need it, they won't listen. And how do you ensure that HPC can become a part of the fabric after you've demonstrated success, right? This is kind of that phase 2 concept. It's one thing to show them how to do it, to work with them and show them that it's possible. It's another thing, and I think people underestimate how much it takes to actually embed high-performance computing into a manufacturing process when they don't have that experience before. Even after a 1-year project, that's hard. Now, this is something that after the last couple of days, I'm feeling a little bit better about. I think there are options there. I think there's an infrastructure that may help this. But how do you get it into that infrastructure? I'm still a little worried about that seed. And then building the ecosystem. Getting access to the cycles and the talent. So I talked about, are there programs we can develop? Can we start working with universities and develop programs in manufacturing side of it? And then I already also touched on the other. So that's my end of my presentation. We have a website, HPC4MFG.org, right? So click the website. I will say that the website is very informative. I'm now in the process of undergoing a kind of a redesign and a reboot of the website because much of what's there I wrote, and I am not a very good writer. Right? So I bring in the experts to help rewrite it and make it a little more readable. But there is a lot of information on the website, all about all the projects, about some of the metrics on the sites. And feel free to send email directly to the program or to Peg at all. Thank you very much for your time.
We have time for a couple of questions. Well, one of them right off is, we heard from NSCI this morning. This sounds like it fits some of what they're aiming to do. Are you linked with them yet? If there is a them?
Yeah, no, we're not linked with them yet.
Okay.
And actually, I missed the talk this morning, so it was sad.
Okay. Well, I mean, the only germane part is that, of course, they're trying to get HPC to more pervasive in industry. So, okay.
Yeah, and we actually heard that a couple times over the course of the last few days, so I'll follow up. Thank you.
Other questions? One over.
Oh, thank you.
So I know you're just getting this off the ground, but looking forward, do you think you're going to focus on including more companies or to to drill more into specific companies that are taking up HPC? So take something like GE, that might be a company that you can then proliferate within the company.
Yeah, that's a really good question, right? So both, right? You want to broaden. I'll tell you, I guarantee GE will have multiple proposals at every solicitation we put out there, right? Because they know the value of it. But you don't want to. You do not want to fund a certain project or fund too heavily for a particular company. So we want to broaden it. We want to get new companies in. That said, if a company's has a really good idea to move something forward that we think would benefit a broader company or a broader industry, we would do that.
So I have a question. Some of the companies that you guys partner with already have substantial HPC resources.
Yep.
P&G, GE, I mean, they have top 500 machines. So what was the idea in focusing in on them? I mean, they seem to know how to do HPC already.
So you're right, and it's if you think of that, I picture in my mind the missing middle part where you've got some people that know high performance computing really well, but they can't stay on the edge of high performance computing. So the labs will always be 5-10 years ahead of them in technology. So they had a great proposal on how to do something that would, if successful, raise the boat for everybody in that industry. So they're kind of leaders, right? And there's two reasons to do that. Either everybody else would benefit while you protect their IP, of course, or they're demonstrating to others that it can be done. So the other thing I'll say about future directions is I talked about growing this program. I hate to say that the program has been wildly successful. We're getting a lot of positive praise, but we've only got one project that's finished, so I can't claim great success. But a lot of other industry areas are very interested in the program and we're talking about kind of franchising it. If this can help manufacturing, can it help the transportation industry? Can it help others? And it can, right? We actually designed it to be very modular and ready for growth. So we're talking to many of the offices in DOE about how do you expand this to be HPC4N.
Hi, good talk. In one of your graphics, you had the bullet that simply said share the results.
Yes.
Can you put a little more detail on that?
Yes, so what we feel is really important, and it's a confusing bullet, I'm sorry I didn't actually clarify that more, is we want to share the impact that these projects have made. That company N worked with lab Y to do something general, and that this was the outcome. This was the return on investment. But in doing so, we also have to be very, very careful about protecting the IP and the secret sauce of that company, right? And so I failed to make that clear in my talk, so thanks for the question.
Okay, I think we're going to need to stop here, but you're going to be here for lunch?
I will be here for lunch, and please come see me.
Remember that face.
Maybe I might, in
Yes.
response to that, just to clarify, tell people about the CRADA, because that's a big part of it.
Yes, so the vehicle mechanism, that's something else I left off my slide, for all of the projects is the standard DOE short form CRADA, and it identifies identifies all of the IP, right? How you protect IP, who has licensing, and how we protect it, and how it's disseminated, right? So everything is clarified there. Thank you very much.